Hey, I'm Luke, and we're here to conquer the JavaScript interview by learning data structures and actually writing the code out, which honestly, like I've said in previous videos, you're never probably going to do an interview, but it's good to know. This is actually a direct part 2 video, so check the description for a link below to part 1 if you happen to stumble upon this video for your first time. We have a bunch of pre-written code already that took care of inserting and checking if the list is empty and printing it out. We're implementing a singly linked list in this video. We even wrote our list node and our linked list class already. So like I said, go check the description below to find a video link, a URL to video part 1 so you can get caught up on what we're doing here. In this video, we're going to be implementing an exists, kind of like a search, so we can look for a value in our singly linked list. Data structure, deleting, we're going to have 3 possible ways of deleting something if it's the head of the list, deleting something if it's the tail or end of the list, and deleting between 2 individual nodes in our list, which will lead it to combine into a single one method to rule them all, and in the darkness bind them, a remove method that we can pass in a value we're looking for, and it will appropriately determine the correct course of action to delete that node from our linked list. So without too much further ado, let's go ahead and dive on into it. And we're going to work on exists, right? So this one's not too bad because we've already done in the previous video a lot of traversal across our list to determine to do certain things. Well, this is the exact same thing. All we need to logically do is go through each node in our list until we find the value we want, and we can return true, or its position if we wanted to do that. Otherwise, we simply say, hey, we've looped through the whole thing and we haven't found it, which means it probably doesn't exist, aka we return a value of false. So let's go ahead and implement this thing and get underway. So all included underneath all our other previous code, so we can kind of work our way with less scroll room here. So let's write our exists method, which I always doubt myself when I write the word exists. I always want to write it this way for some reason. I can't tell y'all why. It's just like my brain's like, no, that's the way it should look, right? But yeah, exists. It's like this. We're going to pass in a value, not like an entire node. I've been trying to do that where I can pass in a value and not like have to find or create a node that has that value. I'd rather just pass in the string value or number or whatever it is I'm storing and be able to find it. So like I said, what we need to do is simply loop through this. And we've been doing so with our friend the while loop using a temp node variable. And that much is going to stay the same. So we're going to start at the top of the list. We're going to say, hey, we're going to set up a variable that will be changing over time as we look at each node. We'll call it the temp node variable. We're going to start it at the head node of the list. And what we're going to do from there is simply loop through with our condition being so long as we have a node, right? So as long as we keep looking at each node, right, until we get to the end, where the end is a null value, that will terminate this loop from running. Basically, this sets it from the beginning all the way to the end or until we tell it to quit early. And what we're going to simply do is say if our temp node's val property, and did I do value last time? I did val, so yeah, don't be consistent, folks. My run rule I constantly break. If our temp node's value is matching the value we're passing into this method, that means we have found it, which means we can simply return true. And I'll add a console log for visual purposes. We'll say val plus has been found. Cool. That'll be our console log, so we know this exists method successfully did its job. And then from there, if that does not return true, meaning it will stop the loop and end the function with our return keyword there, we're going to say, so long as that condition hasn't been met yet, we have to keep this loop running. Otherwise, we're going to be in some trouble here. So we're going to say, hey, our temp node, if it is not a value match, will simply move to the next node. And we do that by simply assigning itself to whatever our current node is linked to, or whatever it's pointing at, if you want to think about it that way, whatever it's referencing. We simply say, move to the next node that the temp node is currently looking at, and the process starts over. Okay? And it is as simple as that. And if this while loop happens to execute all the way through and never actually trigger this if condition to be true, that means we don't have a value. And remember, when we get to the end of our linked list, the .next property will be pointing to null, which will trigger this to be false, which means the loop will pause, or not pause, but finish. And then from there, we can simply say return false for like testing purposes or something like that. And for visualization, we're going to go ahead and just include a hasn't been found. There we go. So now we have our console log value for when it hasn't been found, as well as one for when it has. Let's go ahead and give her a whirl. So we already print the whole list here. That's fine. I'll say list.exists, and let's look for Grog. We know he's in the list right here, so he has to be somewhere in there. So yeah, let's see if it prints out our message correctly or not. Nope, not clear, but npm run dev. Here we go. Oh, I didn't save the file. That helped. Yeah, so we got our print of Pike, Scanlan, Grog, Vax, Percy, and Grog has been found. He is indeed a value that exists in our list. If I switch it to look for, say, Vex, who is not in this list, just names that are actually on my shirt. The characters are right here, now I think about it. How timely. I didn't mean to pick this shirt this morning when I was going to record this video, but hey, it worked out. The characters I'm referencing are on this shirt. Critical Role, check it out. Yes, Vex hasn't been found because Vex is not in this list. So yeah, our exists method is working as expected. If the value is found, it tells us it's been found. If it's not there, then, well, it's not there. And it tells us it hasn't been found. So, oh yeah, that's what I'm talking about. Bully. Now, like in the previous video, I said that inserting stuff could get kind of hairy when you come to this linked list data type, data structure, and it will be a similar issue we have to handle when running ultimately our remove method that will handle one of three possible scenarios. So removing something is going to be probably going to be like the longest time for this particular action, because like with the rest of inserting at certain indexes or searching through, we have to again traverse through the entire list, find where our value is, and then we have to account for one of three possible scenarios. Is this the head of the list, meaning we have to delete the first thing in the list, which isn't too bad? Is it the tail or the end of our linked list, which means we have to know what the previous node was, because the previous node is now going to become the new tail of the list. And then we also have to account for deleting between two nodes. We have to have our previous node and our current node so we can lop it out, right? All we have to do is say our previous node becomes whatever our current node is pointing over to. So basically, here's prev node linked to node. And instead, we're going to say we're going to remove the node, but before we do that, we're going to say this node now points to whatever the current node was pointing to, and that's what's going to happen. And then we're going to combine these three actions into some conditions in one, like I said, one method to rule them all, to remove them all. This one right here, we're going to, just like before, I'm going to pass in the value and not an actual node to get this job done. But again, that's why I'm like taking y'all through the logical steps of how to build these things. But, you know, if you happen to get asked this question in an interview, it'd be weird to implement, and they may have different standards like, oh no, you pass in nodes to remove and not like the actual values themselves. So keep in mind, this is a good high-level concept to understand. If you have questions or comments, get in the discussion below, and I'll be happy to help out wherever I can by making more content. Right on. So let's actually get underway here and begin cranking these out, right? Like I said, deleting something. And we have to be careful with the keyword delete. It's a protected keyword in JavaScript. It's meant for deleting properties off of objects, right? So, I always tend to be careful when referencing the keyword delete. Now, I should have thought about that when I made this one up. Delete first. I mean, again, I'm not using the delete keyword by itself, but I am hesitant. You know what? I'm going to, on the fly, change it to destroy. That's more my style anyway. Destroy. Because, again, we're cognizant about the delete keyword in JavaScript, and I don't want to make a mistake. So we're going to say destroy first is our first possible case. So to destroy the head of our list is actually rather easy. I have to get the head node first. This has been a very common piece of code we've been writing across all of our methods. And then I'm going to simply say the head property will be reassigned to be whatever it was previously pointing to. So we'll say the new head will be whatever the current head was pointing to. And that's it. We have now destroyed that temp node by simply assigning the head of this linked list to be whatever it was pointing to. And that's it. Deleting last. Delete last. or destroy last. My notes over on my other monitor keep saying delete, and I'm like, eh. All right, so destroy last. This will need to know what the previous node was, so it knows what to delete. And here's all we have to say, because again, the previous node will not be the end of the list, right? It'll be the one right before, because then we have to say, instead of pointing to the old tail, we point to null, and it's done. So we can say, off home keys there, prev node dot next is now pointing or referencing null, which means the previous second to last node is now pointing to null, which means it's the new tail, and that thing it was pointing to is gone, therefore it's destroyed the last node. There you go. Then we have our final case, which is, what if we have to delete between two nodes? We'll say prev node and whatever our current or node we're looking at in between is, right? So previous and current, whatever you want to think of them as. Okay? And in this case, we're simply going to remove this thing from existence by saying prev node will be pointing to whatever this node is pointing to. So we're going to say our prev node dot next is going to be pointing to whatever node.next is pointing to, and we've effectively just sliced it out of existence. And that's all it is. Those are our three possible methods that we're going to have for this little thing here. So now we're going to have the one method to remove them all. Remove a value that we wish, and we're going to have conditions to determine which action is going to take place. So just like when we had to insert a particular index in the previous video, we're going to be doing a lot of the same tricks. So we're going to be saying we have to know what the current node and the previous node are, so as we traverse through these things, we can do the logic as required for previous or current node here. So check it out. Let current node equal this dot head. We're going to start at the head of our linked list here. We don't have a previous node next, so I can choose to just leave this undefined for now, or I can just say it'll be starting at the head as well once current node moves on to the next one, right? So I'll just go ahead and assign them both to the head of our linked list. So, you know, I've mentioned that you can ratchet the difficulty up on this kind of a data structure by including more sanitization, if you will, meaning should we actually insert or remove something if, like, we're providing an index or a value that doesn't exist. So it's always a good idea to begin throwing that kind of stuff in, but I don't want to add like 20 new lines of code for this video series. So what I'm going to do is simply keep it simple and say, if this linked list is not empty, let's continue, right? Let's make sure that the list is not empty. If it's empty, there's no point in running through all this. It'd probably have some errors anyway. So again, just a good idea to start beginning to incorporate that into some of my data structure and algorithm videos. As the series goes on and on and on and on until the end of the universe, you know, I can always revisit some of them and really ratchet up their complexity by starting to include things like this, these edge cases as we call them. So we'll say, as long as the list is not empty, we're going to loop through via a while loop, and we're going to say, as long as the current node isn't pointing to null, again, we've been using that trick fairly regularly throughout when looping through our linked list here. We have to make sure that it's not that null end of the tail end of the linked list, so we're going to use that same trick here. And now we're going to say, if we find a match, so this is almost like we're running the exists function and the same concept. We're going to say, if our current node.val property matches the val we've passed in, then it's time to remove it. Okay? And this is where we're going to write some more conditions to determine which action to do when this thing is going to get removed. So basically, we've gone through and looped it and matched our node value. When we have a match, we have to determine, is it at the beginning, is it at the end, or is it between two nodes, right? But before I handle that, just so we are on the same page, because I think I forgot this once before in my test run of this video, we have to make sure that I'm accounting for moving the previous and current values along as long as the loop hasn't found something yet. So I'll get to the actions of removal here momentarily. I'm going to say the previous node will become whatever the current node is. That way it moves along. And then we have the current node become whatever the current node's next property is. So there you go. That is how we're going to progress our while loop, right? We're going to simply move them along in pairs with previous and current because we have to know that if we have to delete between something. So we're going to keep track of both those variables to move this loop along until current node becomes the null pointer, which means we'll get a false and it'll stop the loop. So back over to here. Let's say we've progressed, and we found something to delete. Well, what if it's the beginning of the linked list? If our current node is the head of the linked list, then all it has to do is run this.destroy first because it's the head of the list. And we're done, right? I suppose we could just return blank or do nothing because, well, it's done its job here. Then we can say, and again, I want these conditions to be checked, so we can always say something like this, or I can say, otherwise, if our current node .next is pointing to null, that means we have gotten to the end. But again, remember, it's not, we've gotten to the end, there's nothing to remove. We've gotten to the end because, and we've also figured out that this is the match. So this is the case for, is our value the tail of our linked list? Because if it is, all we have to say is this.destroy last whatever our previous node is, right? There we go. Right, and stop it there. And then otherwise, we're going to have the case where they're between two nodes, because if these specific cases aren't caught, that means we're in between two nodes, and that's what previous and current node's job is for, which means we're going to ask it to this dot destroy between our previous node and our current node like that, and that should round out the code, right? So there you go. That should be what we need to test out here. So let's go give it a shot. I'm going to remove this exists line of code because we know it works. And what I'm going to do is I'm going to do a clean, I'm going to save it and do like a clean run. That way we have the linked list right there. And let's see if this works. So what I want to do to test this here first is, I'll do a blank line console log so we can have some space between them. Before it prints it, let's say we're going to remove Pike, who is the head of the list. Let's test the first possible scenario. List.remove the value. Yeah, I don't know how I fat fingered the enter bar there. Pike. I'm shifting my keyboard over. I keep mistyping. Okay, let's save it and see. We should hopefully see an output of scanlen, grog, vax, Percy, null, if it worked. That's what I'm talking about. That's the value that we ended up getting right there. Let's test it now. And remember, every time I'm saving, it's regenerating the original list, which is this top one here. Pike, scanlen, grog, vax, Percy, null. So Pike worked successfully, which means our if condition for removing the head has worked. That was this bit of code right here. If we find a match while looping through and our current node is the head of our linked list, then we destroy the first thing and it moved then scanlen became the new head pointing to grog. Okay? The next test is going to be deleting the end. So let's test Percy at the end of our linked list. So hopefully the save will now point out Pike, scanlen, grog, vax, and then null instead of Percy. Yeah, I thought I was missing a name there. Yeah, Pike, scanlen, grog, vax, null. So that worked. That was that second else if condition. If our current node that we're looping through has a next property that is null, meaning this is the tail of our linked list, we destroy that tail and simply say vax, you now point to null instead of Percy because Percy has been removed because he was the previous end of the list. And then finally, we're going to have to test destroying something in the middle. Let's test out poor old grog here. We're going to remove grog, so it should hopefully print out Pike, scanlen, vax, Percy, null. Pike, scanlen, vax, Percy, null, and grog has been removed in the middle, which is that final else scenario where it said, hey, destroy between two nodes, and it was simple enough to say, hey, previous node, which would be scanlen, you now point to vax, and grog is now gone. And that's how the logic works. So this video is a bit more succinct than the last video, because, again, we already did a lot of the heavy lifting and describing of how to traverse linked lists and their pros and cons here. And again, this is more of an important conceptual process to understand. So maybe after I finish my data structures spiel like intro level data structure stuff in JavaScript. Maybe I'll make like a TLDR video that says what you need to know at a high level with some pictures and some quick bullet points of, hey, array versus singly linked list or stack versus queue, and giving y'all a quick rundown of what you want to know in the interview. Because again, coding all this out is fun. It, again, sharpens our skills, teaches us new ways of approaching problems and how to think about them. But ultimately, their implementation will vary based on your needs. Sometimes we'll have a tail property and a size property of this class that will be generating as we do all these methods down here. So again, the implementation is less important than understanding the pros and cons and their purposes. So I think I'll do that. I think I might do like a TLDR video after finishing data structures, or at least the basic ones I wanted to cover before covering some more advanced ones. So yeah, that's it for this video. Remember to check out the description below for links to Covalence, getting involved in our community. Like, comment, subscribe, all the fun YouTube algorithm stuff. We're really close to 5K, and I want to kind of see us get there soon. So give us a hand, and yeah, I'll see you all in the next video.